Welcome back, guys. This is the second part of how to estimate the diffusivity of a gas mixture. So the first part, we did how to estimate the diffusivity of a gas using Slattery equation. This is the question here, right here. Estimate the diffusivity for carbon dioxide and nitrogen at 373.2 Kelvin and 1 atm, sorry. A, using Slattery equation. We have done that in part 1. B, using Chapman Enskog formula for an ideal gas situation. So that is the second part you are doing now using Chapman Enskog formula. For Chapman Enskog formula, we have the formula as diffusivity AB equal to 0.0018583 square root of T cube into bracket 1 over MA plus 1 over MB close bracket, all divided by actual pressure multiplied by collision diameter AB square multiplied by Ohm's diffusivity AB. So I'm going to explain the parameter. What are they stand for? We have this as the collision diameter. And we have this Ohm's diffusivity AB as the fraction of temperature and potential feed. All right, we have this as fraction of temperature and potential feed. So we have P as the actual pressure. We have P as the actual pressure given from the equation. So first of all, let's label carbon dioxide as A. And nitrogen as B, just as we did in the other part. So check this table overlay, that is the property table for transport phenomena. So for us to get this parameter, that is collision diameter, so we can see the first column that's under Leonard Jones constant. You can see the first column, you'll see this kind of symbol here. So without any alphabet. So check corresponding to carbon dioxide. You can see that collision diameter there 3.996 Armstrong. And collision diameter for B, that's corresponding to nitrogen, is 3.667 Armstrong. So for us to get collision diameter of A and B, that is collision diameter AB, you make use of this formula 1 over 2 collision diameter A plus collision diameter B. Substitute everything in, you have 1 over 2 collision diameter A, that is 3.996 plus collision diameter B, that is 3.667. We have it as 3.832 Armstrong. So the next thing we're going to calculate is the fraction of temperature and potential feed. The fraction of temperature and potential feed is plotted against KT over E, where E over K is the potential feed. So from here, this E over K, we can get it from the property table. That's check EA over K on the table overlay, that is the second column under Leonard Jones constant, you can see this symbol there without any alphabet. Check corresponding to carbon dioxide, that is EA over K. You can see it as 190. Check it corresponding to nitrogen, that is EB over K. You can see it as 99.8. So the next thing we're going to do is to calculate EA over B, that is what? Potential feed for the both A and B. That is EAB over K. We have it as square root of EA over K multiplied by EB over K. So substitute the value in, we have square root of EA over K is what? 190 multiplied by EB over K, that is 99.8. 99.8. So we have it as 137.703 Kelvin. So we have gotten our EAB over K as 137.703 Kelvin. So the next thing is for us to get our KT over EAB. That is KT over EAB is equal to, it can be expressed as what? K over EAB multiplied by T. And K over EAB is the inverse of what? EAB over K, which is 1 over EAB over K multiplied by the actual temperature from the equation here. So substitute the value in. We have KT over EAB equal to 1 over EAB over K, that is 137.703 multiplied by the actual temperature from the equation, that is 273.2. So we have it as 1.98. We have gotten the KT over EAB. And I mentioned earlier that this fraction of temperature and potential feed is against what? KT over E. So for us to get the fraction of temperature and potential feed, so we make use of this property table overlay again. So for the second page, you can see this one is different from the one we have been using. You can see this symbol there, that as the first column. You can see this symbol there as the first column. So as second column and third column, they almost have the same symbol, just that the second column stands for viscosity and thermal conductivity, while the third column stands for diffusivity. So our main concern is diffusivity, not viscosity and thermal conductivity. So what you're going to do is check this value under the column of KT over E, if you can find it there. But if it's not there, we have to interpolate and get the value there. As you can see, this value is between what? 195 and 2.00, because 1.98 cannot be found here. So it's between what? 1.95 and what? 2.00. So we have to interpolate. That is, the first value is 1.95 and followed by 1.98. That's the value we got. 1.98 before what? 2.00. So check the third column. You can see that the fraction of temperature and potential feed corresponding to 1.95 is 1.085, and we are looking for the one corresponding to 1.98. Let's label it as X, and the one corresponding to 2.00 is what? 1.075. So the reason why we are interpolating is to get this middle value. the value exact to 1.98. So how we are going to interpolate is subtract this from this, that is 1.98 minus the initial value 1.95 divided by the final value, that is 2.00, minus the initial value 1.95. Also do the same thing here, the same format here, that is the middle value, which is x, the one we are looking for, minus the initial value 1.085 divided by the final value 1.075 minus the initial value 1.085. So the next thing is to make what? X subject of the formula. Okay, before that, make division of the, that is 1.98 minus 1.95, all divided by 2 minus what? 1.95. So you have it as 0.6 equal to x minus 1.085 divided by 1.075 minus 1.085. You have it as minus 0.01. So the next thing we are going to do is to make x subject to the formula, that is cross multiply. You have it as x minus 1.085 equal to 0.6 multiplied by minus 0.01. So making x of your formula, you have it as x equal to 0.6 to bracket minus 0.01 plus, that is if this is causing the equal sign turn to positive, 1.085. So you have it as what? 1.079. We have gotten our fraction of temperature and potential field, which is Ohm's diffusivity AB equal to 1.079. So the next thing is to substitute all the parameters we have looked for into the Chapman-Enskog equation. So this is the equation, that is Chapman-Enskog equation, diffusivity AB equal to 0.0018583 square root of t cube to bracket 1 over ma plus 1 over mb, all divided by actual pressure multiplied by collision diameter AB square multiplied by fraction of temperature and potential field AB. So to substitute everything into the formula, we have diffusivity AB equal to 0.0018583 square root of t cube. From the equation, we have t as 273.2 all raised power of 3 into bracket 1 over ma, that is molar mass of carbon dioxide, which is 44.01 plus 1 over mb, which is molar mass of nitrogen, that is 28.01, all divided by actual pressure from the equation, which is 1 atm multiplied by collision diameter square. Collision diameter, we have it as 3.832 square. You square it multiplied by fraction of temperature and potential field, that is, we have it as 1.079. So calculate this, you have it as diffusivity AB, you have it as 0.128 centimeters square per second. So you can see that everything is very easy according to what they asked us to find. So if you find anything difficult in this question, you can mention it in the comment section so that we can all treat it together. So if you find this video interesting and helpful, make sure you like and subscribe. So wait for the next video, which based on the third part.